So, yes, in the previous class, we were seeing about the engineering materials, the classifications, and all other things, right? So, here today, let us see about few more metals and non-metals, that is, ferrous metals and non-ferrous metals, okay, right? And we'll take a look into few more alloys also. Okay, so now, so basically, if you draw a chart of the materials that can be classified, looks like this, where we have the first one to be metals and their alloys, and then we can have ceramics, that's a different group of materials, and polymers is the third one, and then we have the composites. Uh, that is the latest materials that is being used in today, right? In many applications. So now this metals can be further classified, as we already know, as ferrous metals. That is mainly it consists of iron in it. Okay, and the other materials which do not consist iron as a major portion are the non-ferrous metals, right? So here is this is the sub classification for metals in simple two steps. Okay, so we'll see this. We'll come to the other classifications of metals and ceramics and composites in the later on stage. So now let us focus only on the ferrous metals and non-ferrous metals and their alloys. Okay, so we have now, if we take a look at this, so this metals can be, as we know, it can be classified as ferrous and non-ferrous, where it can, once when it is ferrous, this can be classified as pure iron. Okay, so the other one is ferrous alloys, because in major of the cases it consists of carbon content in it, right? So coming to non-ferrous, it can be again classified as non-ferrous metals, the pure forms. The other ones are the alloys that we have. So if we take up the non-ferrous metals, we'll have copper, zinc, lead, gold, silver, aluminium, magnesium, right, zinc, and so many other materials, right? So many other metals. So now let us go to this in a little bit in a proper manner, so that we understand about the classification of ferrous metals. So this ferrous metals, though we get the iron from the iron ore, right? So that will be is called as the pig iron that we get, right? And then that can be further classified on the cast iron, that is content of carbon and other contents in it, right? So that can also be bought in, right? So there we have this cast iron, as we have spoken, as we have seen yesterday. We have different sub classification inside this. One is the gray cast iron and the white cast iron, which we have already discussed in the previous class. And there are few more, that is the malleable cast iron and the ductile cast iron also, which we will see today. Then apart from this, we do have about the wrought iron and steel, right? So steel majorly we come across in our day-to-day life in so many places. Okay, so here in steel, what we can get is that, so yes, so the steel can be further classified as carbon steel, alloy steel, okay, and tool steel, right? Three classifications of the steel. So this carbon steel we have seen yesterday. One is the low carbon steel, then the medium carbon steel, and the high carbon steel. Where in low carbon steel it is ductile, little bit soft in nature, but it gets corroded quickly. Medium carbon steel, the carbon content is little bit higher. Okay, so it becomes more hard, strong, right? Corrosion resistant also. High carbon steel, it is going to be very brittle, okay, and high corrosion resistance, so it is also going to be very hard also, right? So the next thing is that when we go to alloy steels, right? So in this alloy steels we have many varieties. One is the stainless steel, right, which we use it in stainless steel. Again, there are so many other standard stainless steels that is available, like SS314, SS314L, SS410, right? So like that. So as in general, we can have it as stainless steel. Okay, so in stainless steel, we generally make use it for our utensils, right? The top or the covering body that is made up of metal for the gas stoves, okay, are also made up of stainless steel only. Chromium steel, okay. So in chromium steel, this will also look almost like stainless steel, but the chromium content in this particular type of steel is very high, so it becomes very much corrosive resistant. Okay, they cannot be corroded so easily, right? So that is a different form. Nickel steel, where nickel is also going to be a major portion next to the iron content in this particular type of steel. Manganese steel is another type, molybdenum, and tungsten steel, right? So tungsten steel is used where we want to have where we have applications related to high temperature regions. So there, in those particular types, we will have we will use tungsten steel because it has got hardness even at higher temperatures, right? So in that cases, they will use tungsten steel. The other one is the tool steel, that is steels meant specially uh, for cutting purposes, right? To cut metals, right? To cut metals in manufacturing sectors and all. So here for machining purposes, they will use high speed steel, shortly called as HSS. Okay, right? So these are the different types of steel that is there. Okay, so now let us take a look about the uncovered portion. Now, as a pig iron, that is the directly extracted from the ore from the blast furnace. Okay, so which has got very high carbon percentage and other impurities also. So we will have about 92% iron, 3 to 4.5% carbon, right? Silicon is going to be present, 2% up to 2% sulfur, and all those things are going to be present. So this type of iron will have properties like this. So it will be very hard, okay, and very brittle also. Very hard and very brittle also, right? Okay, so now going to the wrought iron. Okay, in wrought iron, what we have is that it is going to be very low carbon content, so it's about only 0.02% carbon, 0.12% silicon, 0.018% sulfur, right? And some other impurities, maybe some other like phosphorus and all. Excuse me. Yeah. Now this since it has got lower carbon percentage as well as silicon also, this type of iron will have little bit soft in nature, ductile also, they will not be brittle, toughness will be high, they can be easily machinable also. Okay, they can be easily machined, they won't be so hard to be machined, right? So they also have corrosion resistance also, so they made use in making pipes and water pipes and all those things, right? So we generally see in our households we have these water pipes, okay, where nowadays we have come up with PVCs, right? So even now we can see with some of the pipes made up of iron. So it is actually the wrought iron that has been these water pipes are being made up of. Also the gates and other things, the olden days gates and all these things are made up of this wrought iron. So they'll be very hard and very quite heavy in weight also. The density is quite high. So they used to make use of this for fences and gates and all those things. Right. So yes, cast iron. So cast iron, we have seen this. Okay, so it consists about 2 to 4.5% of carbon and a smaller amount of silicon and sulfur also. So they're going to be very brittle, very strong. Okay, and good fluidity. That is, they can be when it has been heated to red hot temperature, they get converted into uh, the liquid phase. Okay, so they can start flowing in a very easy manner. There will not be so much of resistance to flow, that is the viscosity. So during this, with this we can have good since because of its easy flow nature, it can this metal can flow even into very narrow regions and it can fill that particular place. So there will not be any kind of not much casting defects and all. Right. So gray cast iron, yes, and white cast iron we had seen yesterday, right? In the malleable cast iron, yes, this has been produced by annealing. That's a type of heat treatment where we want to change certain characteristics of this particular type of material. That is, in this case, it is a cast iron. Okay, so where nothing but what they do over here is that we heat treat it. Okay, we take this metal to a particular temperature, that is about 870 degrees centigrade, okay, and maintain it up to for 25 to 60 hours, so that there's a small change in the grain structure, the formation of the metal, the atoms. For our simple understanding, it is made up of grains, which will, when we see this metallic specimen under a microscope, it will almost look like our human cell. Okay, so for our simple understanding, so a group of cells are coming together. So that in the form of in the similarly, when we take a section of metal and it is being polished, and when we see it under a microscope, we can see like this, like cells with grain boundaries, okay, and many other features inside this, right? So that will be altered when we do certain type of heat treatment to these types of metals. So we call those as the grains. So the grains will get modified. Once the grains are modified, the properties of that particular material or metal will change accordingly, right? So that is why this is going to be unhealed, okay, and slowly cooled. They'll raise it up to this particular temperature for and keep it for certain time, and then it is going to be slowly cooled. So there, what happens is that what was cast iron was a brittle material. Once we do this heat treatment, it is going to become malleable, okay, and it is going to be easily machinable also, right? And it will have moderate strength, toughness, and corrosion to resistant also, right? So that is about the malleable cast iron. So steel, carbon steel, alloy steels, and tool steels, right? So low carbon, medium carbon, high carbon steel, we have seen it in the previous class. Okay, right? So now let's go to alloy steels, where, as we know, it will generally consist of some other material like carbon, then chromium, nickel, or manganese, like that. Okay, so over here in alloy steels, now when we look at stainless steel, it will have contents of chromium from 11 to 25% depending upon the type of property that we need. Why we are going to add chromium is that chromium will help in corrosion resistance. Each metal has their own properties. Now if you look at copper, they are very good conductors of heat and current, right? So when we add copper, some of those properties will get added up. So similarly, chromium has got the property of corrosion resistance and giving a very shiny smooth surface finish. So wherever we want for applications where it has to be corrosion resistance, so they will go in for adding chromium into the material or metal, right? Okay, and they don't get stained, they don't corrode so easily, right? So that is the major constituent after iron is the chromium in this case. Also it will have some portion of nickel and carbon in it. So if you look at the manufacturing, where and all it has been applicable in kitchen utensils, sink, food processor equipment. So we see some of the times where in the food processing industries they will have huge tanks and all those things. So they will all be made up of this particular type of material. Okay, right? Okay. So next is that yes. So nickel steel. So apart from iron as a major chemical composition in nickel steel, it will contain 3% of nickel, which is a very hard material. Okay, and has got a higher temperature when compared to that of iron also, right? So this is being made use in measuring instruments like a vernier scale and other things. Okay, clock pendulum, because the coefficient of thermal expansion is very less. Okay, and used in axles, piston rods, that is for high-end versions like the railway engines and ship engines and all. So manganese steel, yes, manganese has got a different uh, characteristic. So adding manganese will also help in in wear resistance. So they are not so easily to be worn out. So adding manganese to certain percentage into steel or iron will give more wear resistance. So they are generally used in shafts and gears and axles. Also their toughness will be increased. Okay. Now we have seen about most of the classifications of iron and steel. Now, but we since iron and steel have uh, have high densities, okay, and it is not optimal, that is, it is not the exactly suitable metal to be used in many applications, because if it's heavy weight, okay, corrosion resistance, so it is not optimal. They are quite heavier in places where we don't need at all, right? So in those cases we have to find out certain other metals where it has that particular desired properties. So the non-ferrous metals, if we look at it, okay, they are generally having good strength to weight ratio, then good strength to resistance to corrosion, light in weights, okay, right? Strength to weight ratio is nothing but the density that we can assume. So even if I have 1 kg of metal, the strength of it is very high when compared to iron also, we can say, right? So like that, strength to weight ratio, if we match this with, the weight, if I have 1 kg of aluminium and 1 kg of iron on two ends, okay, and if I want, say for example, the hardness should be for a particular value, say for 50 HRC, and iron has got about 80 or 140 HRC, which is not required. We can choose aluminium itself over there. Okay, so in that cases, this is what is called as the good strength to weight ratio, right? Okay, electrical and thermal conductivity is easy of fabrication also. So non-ferrous metals can be classified as metals as well as alloys once again. So metals, as we know, it can be aluminium, copper, lead, tin, zinc, and all these things. Alloys will be a combination of these metals: brass, bronze, duralumin, like soldering material, right? These are all alloys. Okay, so yes, we have seen about aluminium, like it's a silvery white non-corrosive metal. Okay, soft in nature, obtained from bauxite ore. Okay, and it has got very better good strength to weight ratio. That is, it is very light in weight. Okay, highly ductile in nature, good conductor of electricity and thermal conductivity also. Resistance to corrosion is also fairly better, right? So application used in aircraft parts, right? So that and few aircraft parts nowadays we make use in engines, not actually aluminium, pure aluminium. Pure aluminium is used in these cabins, the frames, and all those things. Okay, for domestic applications and all those things. So alloys of aluminium. So as I said in the previous class, one is the duralumin, which is most preferred material in aircraft. Okay, so which has got the, after aluminium having 92%, 3 to 4.5% will be copper, 4.4 to 0.7% of magnesium, right, and some percentage of manganese also. So this will make it as good as steel. Okay, as good as steel almost. Okay, low resistance to corrosion also is there, so it has to be coated with aluminium. Okay, right. So magnesium, so 95% aluminium, 5% magnesium, so this is called as magnesium. Okay, it has got good damping properties and high thermal conductivity also, right? So a few other application, there are several parts in the aircraft. Okay, so depending upon the application and the properties of the metal, that particular type of alloy is being chosen, right? Okay, so now when we go to copper, as we all know, it's soft, malleable, ductile, good thermal resistance and, sorry, thermal conductivity and corrosion resistance also, right? Okay, so now let's go to the alloys of copper. So in alloys of copper, so we have seen about brass in the previous class. So it is majorly made up of copper and zinc. So 50 to 80% of copper is the range in variation that we can expect in a brass material having copper. 19 to 40% containing zinc. So zinc is added to copper to improve its machinability, strength, and hardness. The moment we add zinc to this copper, okay, its machinability improves. Okay, it's easy to be machined. Its hardness is also going to improve, right? Good strength and ductility is also going to be there, right? So this is used in marine fittings, valves, right? In bolts, right? And all those things. So if you see some cases, we'll have this made up of brass, right? Okay. So some olden ornaments like olden in the previous days they used to have making use of brass. Okay, some electrical fittings also has been used. Okay, so then is the bronze metal. So bronze majorly consists of copper and tin. So 88% copper and 11% tin. Okay, we'll get a bronze material. Okay, and also some few cases, some other constituents like phosphorus and lead can be added up. Okay, right. So it is going to have good strength compared to brass. Okay, and easily machinable. Fatigue strength is going to be good, right? Okay, so used majorly used in bell metal and gun metal. So what we see, the bells especially in the temples and in other cases. Okay, so and the gun metal, okay, the metals used in gun, that is for bullets and other things and all, they are actually made up of bronze. Okay, they are actually made up of bronze. Okay, it can be easily machinable, they are hard in nature, and fatigue strength is high. They don't get corroded also so easily. Right. Okay. So gunmetal, yes. So this is the combination for gunmetal: 88% of copper, 10% zinc, and sorry, 10% tin and 2% zinc will be added, so that we get gunmetal, also used in marine fittings, pumps, and other cases. Okay. So bell metal will have about 75 to 80% copper, and remaining will be tin only. Right. So yes, that is about uh, the bell metal, gun metal, and all those things. So now when we add up lead, what happens to these? So lead is actually a soft metal, malleable in nature, having low melting point also. So very poor tensile strength. That is, it can be expanded easily and it gets broken into pieces. Right? It can be cut away very easily. Right? It is a little bit toxic in nature also. Okay, these are the some of the mechanical properties. Okay, so it is majorly used in soldering since it has got low melting point. Okay, right? Okay, so yes, in the painting industry, water pipes also, lead has been used as a coating agent. Okay, right? And yes, so alloys of lead, it is mainly used in for making soldering wires. Okay, so lead and tin will be mixed together so that we get the soldering material. Okay, so there it is being used. Okay, then lead foils. Okay, and it was also used in this cans, aluminum cans also. So it has to, some of the times, especially for food storing of cans, it has to be, it should not contain lead, especially because of its toxic in nature. So that is why they say it should not, those particular types of applications, lead should not be present in it because it will become toxic. Okay, right. So zinc is a bluish white material, very soft in nature also, little bit, I mean compared to aluminum, it's little bit softer in nature. Okay, right. And it has got a low melting point and boiling point, good resistance to corrosion and castability also. So zinc, where do we use? We see something's called as galvanized iron, right? For these pipes and all those things, water pipes. The outer diameter will be they call it as GI pipe, nothing but galvanized iron. Okay, and even when we see in the sometimes we will see this electric poles that has been used for lighting purposes on roads. So over a period of time during regular maintenance, they will coat this pole, which is made up of iron or any other material. They will coat it with a silvery paint, nothing but zinc. Okay, because it has got very good resistance to corrosion. Okay, right? So it is actually nothing but a zinc paint only. Okay, because they wanted to prevent it from corrosion, because it has been continuously exposed to sunlight and rain and so many other changes in weather. Okay, right? So there they will make use of uh, zinc. Okay, yes. So tin is again a silvery material. Okay, soft, again malleable and ductile, also having low melting point. That is why it is going to be mixed uh, with lead over here to make soldering material. Okay, so tin can also be coated, tin cans, right? So they're actually made up of tin. Okay, uh, a major constituent. Okay, and alloy material to make the softer soldering material also. Yes, so uh, these are some of the metals, then non-metals, then alloys that is present that we have to know in general, because there are every portion in this has several sub classifications. So if we take up aluminium itself, as I mentioned in the previous class, we have not just restricted to duralumin and magnalumin and so on things. There is many more series of standard alloys that is available for aluminium itself for different applications. So similarly, it is present in steel, right? So in steel we have SS stainless steel 314, 314L, 410, right, and many other series also. So similarly, it is the case with copper, lead also, right? So this is all about the metals, non-metals, sorry, non-ferrous metals, okay, and alloys for that. Okay, so next is that we will have a look about the polymers. So polymers, what are the properties of polymers? Basically, they're made up of uh, the polyesters. Okay, right? So they have a continuous change of repeated chemicals bonded together. Okay, right? So we have polythene, polyvinyl chloride, nylon. Okay, and many other polymers. Basically, all of these have these common properties. They have very low density, that is very light in weight. Okay, exhibit good corrosion resistance. Okay, they don't get corroded so easily. Then they are very good in moldability. That is, it can be brought to any shape very easily, right? They can be brought to any complicated shape very easily. Low resistor, I mean low coefficient of friction, that is the friction in moving parts is going to be very less where we have polymers, right? Because they have a very smooth surface finish that can be created. Okay, okay, so that is the next point also. But the other thing is low mechanical properties. Their hardness, tensile strength, compression strength, and all these things are very low when compared to metals. Okay, so these are the properties of polymers. So industrial applications, they use it, as we all know, as it has been mentioned here also. Polyvinyl chloride, nothing but the PVC, shortly called as, used in making pipes. Okay, the same material is also being made use in our syntax tank and other overhead tanks and all. So those particular tanks, packaging materials, right, for insulation, that is for the uh, insulation present on our electrical wires. Okay, some of the automobile parts also has been made up of these polymers, right, used in cloth industries, because there is some materials are made up of nylon, right, and for protective helmets and other things also it is being used. So the two major classification of polymers is, one is the thermoplastics and the other one is the thermosets. Okay, so thermoplastics, they get softened and get transformed by the application of heat. Okay, and when it has been cooled down, they take up the shape that has been present, by which it has been surrounded by. Okay, so on application of heat, this will become softened, and we can get it to any shape again and again n number of times. Okay, okay, so but here all we require is only the heat that is majorly required for them to be softened up. Yeah. So majorly thermoplastics are, examples are polyethylene, okay, and propylene, PVC also, right? Okay, so what they have, low melting point, good wear resistance. Okay, they don't react with chemicals so easily. So that is why some of the chemical tanks will be made up of these thermoplastics. Okay, and they're highly plastic in nature. Okay, and they can be heated and cooled any number of times. So that means this type of plastic can be used, brought to any shape. Okay, reformed to any shape again and again n number of times. Yes, the other type of polymer is thermoset polymers or thermosets. Okay, so what happens over here is that uh, on application of heat, and cooling only once they take up the shape. But the next time that we do, they will not get melted. They will only get melted, but they will not become soft, but they will become hard enough. Okay, and it cannot be molded to any other shape the second time. It is only one time process. Only once we can melt it. Okay, and it can be brought to a required shape. That's all. The second time we do it, no, it is not going to happen. They are going to become very hard. Okay, though it may melt, it is going to become very hard, and it cannot be remolded at all. So some of the example is epoxy resin, polyester resin, vinyl esters. Okay, right? So they are stronger thermoplastics, well suited for high temperature applications. So we can use only thermoset plastics, but not thermoplastics. Okay, right? Then high strength and high hardness when compared to thermoplastics. Okay, they cannot be re-softened once they have been set and hardened. So because of this reason only, it is called as thermoset polymers. Okay, once it has been set, yes, that's the end of it. So what we have is the telephone receivers, that is the handles of the telephones that is being made up of, right, some automobile parts, right, and the electrical switch boxes that we see, the switches, the electrical switches, right, all these are made up of thermosets only, right, they are made up of thermosets. So that is why whenever we see, once there is any kind of short circuit, this switch or that particular portion where it is being heated up will melt down. Okay, and that particular region, the plastic will become very hard and change its color. It cannot be brought back its to shape. It has to be only thrown out. That is that. So these are made up of thermosets. Okay, these are made up of thermosets. Now if we take a look at the difference between the thermoplastics and thermoset polymers. Okay, they can, so thermoplastics can be deformed easily on heating and can be bended and can be reformed again and again, but that is not the case in thermosets itself. It is only one time. Once they are molded, that's the end of it. So thermoplastics can be recycled, thermosets cannot be recycled. Okay, so thermoplastics suitable for low temperature applications, but thermosettings are used for high temperature applications. So these thermoplastics are soft and less stronger, but thermosets are hard and stronger when compared to thermoplastics. So during the manufacturing time, the curing cycle, that is for them to get set and become hard, it takes a little bit lesser time. The cycle to complete the one process to get one mold is of plastic, thermoplastic is shorter duration, but here in thermosetting it takes a little bit longer time. Okay, right, and the next thing is in thermoplastics they have higher molecular weight. Okay, and resins is cost is high in thermoplastics, and here the cost of resin is low, right. So you can write some of the applications for thermoplastics and thermosets. Okay, right. So we'll stop here for today and continue about composite materials in the next class.